Hello, Algebra fans. I've really been missing you guys this week. I wish that factoring was something that we could learn together in person, but unfortunately that's just not the case right now, right? Thank you to those of you who filled out the survey. I really appreciate it. We are going to continue our adventures with factoring, right? Continuing our adventures with factoring. So, today we are going to do our first method for factoring a trinomial. So that would be ax squared plus bx plus c, just a general trinomial like that. And we are starting with our essential question, which is, how do I factor a trinomial with a leading coefficient other than 1. So what if a is not 1? That is the question. What do we do then? So our first method, which we're learning about today, and we'll learn about the second method tomorrow in our day 3, is to factor out the monomial first. So we talked about greatest common factors. If we take a look here, we want to find the greatest common factor of 5x squared, 15x, and 10. So I'm going to list out their prime factorizations. 5x squared would be 5 times x times x. 15 is really 3 times 5, and we have an x. And then 10, we know is 2 times 5. So there's their prime factorization. So if I want to find their greatest common factor, I can see that 5x squared and 15x both have an x, but 10 does not. So x is not a greatest common factor. But they all have a 5. They all have a 5. So if we factor 5 out of each, what are we left with? What are we left with? Well, if we take 5 away from our 5x squared, we have an x squared. If we take 5 away from the 15x, we have a 3 times x, or 3x. If we take 5 away from 10, we're left with 2. So if I take my 5 out, then we are left with x squared plus 3x plus 2. Hey, this looks like what we were doing just the other day with our 7.5, right? Factoring a trinomial. So now we have to ask ourselves, well, what multiplies to 2 but adds to 3? Well, we know 1 times 2 makes 2, and then 1 plus 2 makes 3. It's kind of like a puzzle, right? Like Mr. Prey said. So we're going to have 5 on the outside here, and then x squared plus 3x plus 2. And then this, I know I can break down even further. I've got my 2 sets of parentheses here. So I'm going to have an x plus 1 and an x plus 2. All right? So this method is not too much more complicated than yesterday's. We just have that extra step of we have a greatest common factor that we can take out. So let's try another example together. Example number 2, we have 4x squared plus 32x plus 60. So we want to find the greatest common factor of all of these. I will give you a hint. They're all even numbers. So we know at least 2 goes into them all. But we have a 4 here as our a value. That's a good thing to start with. It's great if we can factor out our a value. So our greatest common factor in this case is 4. So then when we think about what we're left with, well, we're going to be left with an x squared. 32 divided by 4 is 8. So we'll have an 8x, and then 60 divided by 4 is 15. So up here I have 4, and then parentheses, x squared plus 32x plus 15. So now I can ask myself, well, what multiplies to 15 but adds to, oh, I wrote 32. Silly Miss Frisch. This is why I tell you guys, I still make mistakes. But adds to 8. That's hard to see. So it needs to add to 8. Well, things that multiply to 15 would be 1 times 15, or we could have 3 times 5. So if I think about those two, which of those is going to work? 1 times 15 or 3 times 5? Yeah, hopefully we can all see that 3 plus 5 would make 8, and 3 times 5 would make 15. So we have a 4 here, and then x plus 3, x plus 5. It doesn't matter which order you write these in. It could be x plus 5 times x plus 3. It doesn't matter. So this is our final answer right here. All right, let's try the next two together because these are a little bit different. All right, they have some negatives in them now. So with our next example, we've got 3x squared minus 15x minus 18. We want to find the greatest common factor of all those. Hint, hint, what's your a value? What's your leading coefficient? Yeah, 3 is the greatest common factor. So then when we think about what's left, we've got a negative 15x here. So we have x squared left over, and then negative 15x, if we divide that by 3, we get negative 5x. And then negative 18 divided by 3 gets us a negative 6. So we are going to have 3 parentheses x squared minus 5x minus 6. Oops, there we go. I'll keep my color coordination going. So we need to figure out what multiplies to negative 6 but adds to negative 5. So now we have some negatives thrown in here. We have to be really careful. It's where it just gets a lot more tricky, right? So we know that negative 6 could be a positive 1 times a negative 6. It could also be a negative 1 times a positive 6. But that's not the only thing that multiplies to make 6. We also have 2 times negative 3, or negative 2 times positive 3. Well, if we do negative 2 times 3, that would be negative 2 plus 3. That gets us a positive 1. Positive 2 plus negative 3 is a negative 1. Neither of those work. So let's take a look at our 1 and our 6's. If we have negative 1 times 6, we get negative 6. But negative 1 plus 6 is a positive 5. So that means we must want the positive 1 and the negative 6. So we would have our 3 here, and then we do our 2 parentheses. We'll have x's for the first position, and one of them will be an x plus 1, and the other one will be an x minus 6. And we can do FOIL to it if we want to, or distributive method, or area model. Any of those things will work, right, to double check our answers. Or you can look at me and say, cool, I like it. All right, the last one that we're going to do together is down here at the bottom. It's negative 2x squared plus 2x plus 24. So we want to find the greatest common factor. Now, some of you might look at me and say, well, that's 2. And I agree with you. There is a 2 there, but we want to get rid of the entire a term if we can. So it's not just 2, it's negative 2. All right, negative 2 is our greatest common factor. So then we think about, well, what's left over? We know we're going to have an x squared. 2x divided by negative 2 would leave us with a negative x, right? 2 divided by negative 2, that's negative 1. So this is a negative 1x or negative x. And then 24 divided by negative 2 would be a negative 12. So we're going to have x squared minus x minus 12. If you like putting your 1 in here, your ninja number 1, that's totally fine. I have not put it, but either way works, right? We need to now figure out what multiplies to negative 12, but adds to make negative 1. So the multiples for 12. Well, we know that we have 1 times 12, so that could either be negative 1 times 12 or 1 times negative 12. We also have 2 times 6, which could be negative 2 times positive 6 or positive 2 times negative 6. And we have 3 times 4. So a negative 3 times a positive 4, or a positive 3 times a negative 4. And we need to make negative 1. Well, I know 1 and 12 are not going to make 1. That's too big a difference. Negative 2 plus 6 would be positive 4. 2 minus 6 would be negative 4. So those don't work either, which means 3 and 4 are going to be our best bet. So if we do negative 3 plus 4, that's a positive 1, or positive 3 minus 4 is a negative 1. So this is the one we want. So we've got negative 2 on the outside, And then we have x's for our first positions. It'll be x plus 3 for one of them, and x minus 4 for the other. So it's one step more complicated than yesterday, but not too bad, right? I want you to try some example problems, okay? So I'm going to move this page. I want you to pause the video and try some examples. We'll go over it in just 1 minute. All right, let's talk about the answers. This is a little bit more review from the other day, right? We have all leading coefficients of 1s, but I just want you to practice a little bit more because this is hard. Like I said, this is not something I would ever choose to teach you via distance, but it's what we have to do right now, right? So, answers. You should have gotten x plus 1 times x plus 6, x plus 1 times x plus 8, w minus 1 times w minus 3, n minus 5 times n minus 7. I'm going to slide this up a little bit. X minus 2 times x minus 12, x minus 3 times x plus 5, y minus 2 times y plus 15, and then v plus 6 times v minus 7. All right, that is it for today's notes. Email me if you have questions. I know that this is challenging. It really is. It's challenging. And this is so important, guys, because you're going to see it again in Algebra 2. So it's something that's not going away. When you get into higher and higher math, this is really essential. Please, please, please email me, reach out to me if you have questions. Skills practice is posted to Big Ideas.